Hello, it's Scott Manley here. I've talked about the Titan Submersible implosion from 2023 a couple of times. It's one of those sort of engineering problems which unfortunately involved death, but it also involved a lot of really dubious engineering which came out in the analysis and the investigation afterwards. Now, there have been a couple of new reports published in the last few weeks that I would really like to talk about here because I think you guys would all find it super interesting. So yeah, this is like the remains of the wreck. Well, first of all, the thing I want to talk about is the NTSB. They finally have released their report. So the National Transportation Safety Board, I read a lot of NTSB reports because they're usually the people involved in investigating plane crashes, right? Because it's transportation. They also involve in things like highway crashes, marine accidents, railroad, and under here there's also pipelines because, you know, if you've got a pipeline moving gas or oil between states and it fails, that's technically a transportation issue. So yeah, they've released their full docket with all the supporting documentation. But before I look at this, I want to flick over to the Coast Guard site. Now, they also published their final investigation somewhere, their Marine Board of Investigation report in August. But the one that I want to look at here, just for a moment of, well, honestly, to get a giggle. And I know people died, but this is pretty funny. So they interviewed an expert in submersibles, right? They obviously they talked to a lot of people involved with the company. They talked to some other people outside the company who are experts in the field. This particular interview was redacted, right? So we have Lieutenant Commander Redacted talking to Mr. Redacted. And this is one of the worst jobs of redaction ever. So, interview of Redacted by Lieutenant Commander Redacted. So, how did you get yourself started into submersible operations? Well, I'm sure you're familiar with my film Titanic. Oh, gee, I wonder who that could be. Like, we got this far before the redaction became clearly irrelevant. This is actually a really fascinating document. James Cameron goes on into a lot of detail about his development of his submersible, and he also really making a case to the Coast Guard that actually it's totally possible to operate submersibles safely for tourist operations, but they've had to sort of work around this. And this is actually one of the interesting conclusions, that the licensing in the US basically said, no, you can't take a tourist submersible below 150 meters. Well, both the NTSB and the Coast Guard report seem to think this needs to be re-examined because the inability to run a deep-sea tourist submersible was one of the reasons why OceanGate was just avoiding any licensing whatsoever. Now, having said that, Stockton Rush clearly wasn't prepared to pay the amount of money that was needed to build a proper classified submarine that could handle those depths. But, that's one of the conclusions they come out with. So anyway, the actual US Coast Guard report is 335 pages, goes into a lot of detail, very much worth reading. But I'm going to go over here and look at the docket here from the US Coast Guard. So we have this, like all their exhibits are split into multiple sections. You've got the documents that they collected. They analyze the operations, the materials. I've previously gone a lot into the materials, and we'll come back to that. These were all published last year. They have interviews. They have analysis of the survival factors, which means the search and rescue. And there's stuff that comes out here, for example, that one of the first ships on scene that had deep-sea submersibles, they were limited to 3,000 meters, but they decided to try to take their ROV down below its rated depth, and they destroyed it. They had a second one that at least went down to 3,000 meters, and they decided not to lose that. But people got on scene quickly. The real conclusion of the survival factors analysis is that, OceanGate were supposed to have an ROV with them or something on site if they were doing this, or at least that's a good recommendation going forwards. But the most interesting thing here is this section here, where the NTSB does their forensic stuff and tries to analyze electronic devices for data which may be relevant to the dive. As you know, data on this dive was actually really important because the acoustic monitoring system, the real-time monitoring system, they were able to show changes to the hull performance between different dives. So we're going to look at these. So first of all, we have the electronic devices report. And what this is looking at a bunch of stuff that was recovered from the ocean floor. This is stuff that was recovered from inside or nearby the wreckage. And obviously it's been subjected to some pretty violent forces. And this is really perhaps the most interesting thing I'm going to show here. What happens to the server room that is in the back of the submersible inside that titanium globe, titanium hemisphere? What does it look like after being crushed? That's what it looks like. That is just like mind-blowing. So yeah, the computers were all in this hemisphere at the back. There were 3 little PCs, there was like a switch, there was radios, there was some like cabinets, supporting structure, some other miscellaneous pieces of hardware. And there you can see a lot of the cables coming out here that were plugged into the switch. You can see over this side sections of the fins here, for the cooling fins from the PCs that have been squished down. Now, they actually have a photo later in this document of what the server room looked like beforehand, and you can see like the switch down here, these 3 PCs, radio, there's like a red metal structure. So I think this photo relative to that is actually upside down. So if we flip this one over, we can get a better idea of how this compares. So these are Nuvo 5000 LP, fanless PCs that were in the back there. And they had 3 of them for redundancy to run their like data logging and everything else. What's also fascinating to see here is the amount of charring and heat damage. Now, we've previously mentioned that when you take a few cubic meters of air and squish it down by a factor of 400, 400 atmospheres of pressure, then it's going to heat up like the air inside a diesel cylinder inside an engine. Well, that's going to heat it up to some pretty high temperatures. Now, I was skeptical of just how much heat damage we would see, because there's only a few kilograms of air, really only like a kilogram or so of oxygen, so it can't really burn everything, but it can char the surface. And that's what we're actually seeing here, is like some of this material appears to have been charred. Now, and I thought that some of this stuff might be due to lithium-ion batteries that were in there, but as far as I can tell from the operation docs, they used lead-acid batteries inside the submersible. It was the lithium polymer batteries were outside, and so those wouldn't go up like this. There might be some other sources that could cause this kind of damage, but you can look in here. First of all, yes, we've had one of the most violent events that has ever been experienced by a computer, and yet the duct tape still remains attached. You can see like some of the structures, the aluminium structures, which were previously like standard framing material that's just been smashed into a flat shape rather than a square cross section. And these PCs, right? So we've got like the red layer on the bottom, and then the bottom of the PC case, and then that's the top of the PC case, and then these fins. Similarly, another PCB, so on and so forth. So yeah, this is just, it is kind of mind-blowing. I wonder like how hard I think this might have been smashed into like the side of the hemisphere at the back. So if we come back out and I flip this thing back around, we'll talk about a few things here. So yeah, they received 100 pounds of compacted, smashed, compressed metal, plastic, electronic components and other materials. It exhibited signs of thermal damage without typical signatures of having been exposed to open flame. Right? It was exposed perhaps to the heat of flames, but only for a fraction of a second. A section of the mass contains a polar fleece material. Okay, wait. Stockton was famously seen wearing his fleeces all the time. They did not find any they didn't see any human remains externally visible anywhere on the mass. Okay. The mass was suspected of containing a mission computer which would have contained electronic data related to the vessel's performance history, operation, as well as acoustic, hull monitoring and other diagnostic information. Figure 2 shows the installation of the mission computer. Okay, and this is so this is the thing, and we've already shown the standard installation. And then this is the other piece that they got out, and here you can definitely see that fleece material. It's sort of the right color, but having said that, I wonder if they wouldn't have blankets in there in the back. It would kind of make sense to bring blankets as extra supplies, just in case like they get stuck down there, as they did when they had problems operating it. So I wouldn't be too focused on the morbid nature of these particular fleece fragments, but could be. I mean, we know that they recovered his pens and business cards and stuff from sections of his outfit. So yeah, looking back at this. So anyway, look, the team at the NTSB were really interested to recover any data from this that was possible. They also found some other boxes. They were also given other boxes of electronics which were easily identifiable. This looks pretty pristine, and you might wonder, how did that survive this incredibly violent implosion? And I think, given that this has like a circular metal plate here, I think this is probably one of the glass spheres which were in the fairing at the back. So these contained a lot of the electronics for operating like the motors and stuff that had to be outside the hull. And they were in these like glass spheres which were rated to the depth. But because if a glass sphere then would fail or collapse, it would release a bunch of energy, equivalent to like half a kilogram of TNT or pound of TNT. So what you do is you replace the air with something that is incompressible. They fill these with mineral oil. So while these were smashed by the implosion of the primary pressure vessel, the pretty violent forces involved, these things weren't subjected to massive changes in pressure. Therefore, they survived in pretty good condition. The other box had a bunch of fragments here and there. Some of them look crushed, some of them look like they could have come from a sphere. I can't really identify anything here, and as far as I can tell, none of these look like a video game controller. So look, they want to try and recover the data. This is what NTSB does. This kind of forensics is key to so many aviation investigations. So they triaged the material at the Vehicle Recorder Laboratory. It consisted of layers of compressed material. The layers could not be removed or exposed without using significant force and mechanized tools. As such, there was a concern that examination in this manner could damage any memory components. So they wanted to see if memory components were survivable. They wanted to evaluate it. They took a computed tomography scan of the mass, which basically fires X-rays through it, and as you rotate it, you can reconstruct the 3D model. I made a video on X-ray tomography a few months ago at Luma Field in San Francisco. I went and X-rayed an old piece of Soyuz hardware, and then I used their super fine detailed tomography scanner to detail the internal structure of heat shield tiles from spacecraft. That is a fascinating video. Many of you did not watch it. I would suggest you go back and watch it because it is fascinating to see the microstructure of heat shield tiles revealed in X-rays. So anyway, they said if the CT scans failed, they could still do like analysis, looking for these dimensional spaces and stuff. They also were saying like they were looking for NVRAM chips in these SSDs, but they didn't know if it might be like in a RAID configuration, which might either simplify or complicate data recovery. If you've got the same data replicated in multiple places, it makes it easier. But if a contiguous piece of data is split between multiple places, that makes it harder. So they took it to a facility. They used 320 kilovolt CT scans. And unfortunately, that was not powerful enough to penetrate the object. No internal structures or voids were visible in the system, and they couldn't identify any memory devices. Now, they considered using a more powerful CT scanner with higher energy X-rays that might penetrate deeper, but then they thought, well, this might actually damage the NVRAM status, right? So NVRAMs are semiconductor devices. They're moving tiny amounts of electric charge around, and if you hit it with an X-ray, you can make those electric charges move. You can destroy them, you can add them. That would potentially damage the data on there. So they didn't want to do that. So, with that being unsuccessful, they approached the ATF, right? The Bureau of Alcohol, Tobacco and Firearms and Explosives Laboratory. They had a fire research laboratory which apparently does analysis of electronic devices which have been like damaged in fires and stuff like that. So they were going to use tools to take the system apart and try to extract the SSDs that were there. By the end of May, the ATF Fire Research Laboratory had finished the evaluation. They'd successfully extracted 2 PCBs consistent with having come from a 2.5-inch SSD. And they received these 2 PCBs, and we have pictures of them. And it does not look good. So these are what the SSDs look like. These were in the middle of that mass. So you might imagine that perhaps the structure of the PCs and the various, rack mounts and stuff might protect it a little from the extreme forces, but no, these were bent in all axes, and these chips are visibly cracked. They're also missing 3 chips. The ATF, did they just destroy those as well? So yeah, it consisted of at least 8 BGA NVRAM chips. The PCBs were both deformed in all axes, and 3 chips were missing from each. And the remaining chips showed visible signs of cracking and distortion. Such damage is presumed to have compromised the internal silicon dies, rendering the chips inoperable and irreparable. Although, never say never, maybe one future someone will be able to come up with a way to restore this. So yeah, they basically recovered no data from this, but I found that process absolutely fascinating. Now, they did look at the stuff from the other boxes, and they basically said, okay, as far as we can tell, the devices that are interesting don't contain non-volatile memory, or if they do contain non-volatile memory, it's not going to have anything interesting related to the real-time monitoring system. So yeah, that was that report. It was a dead end, but again, a part of the journey. You know what they say, the journey rather than the destination is sometimes the story. So the other one, again, very much journey rather than the story. This is the underwater camera. Now, the underwater camera was mounted on the outside of the hull. It was like a 4K, 12 megapixel camera that was used for imaging. It was a subsea Rayfin Mark II benthic camera. It's a camera that's designed to record the video and still images to a rated depth of 6,000 meters. So this was built like the submarine should have been. Data could be stored to the onboard memory or to an external computer. It's made of titanium, and the camera's front optical window is made of synthetic sapphire crystal. So yeah, they got this, and it was basically not imploded. Again, so this survived the violent event next to it. And if you think about it, right, I've mentioned this before, as a submersible collapses, it's releasing a lot of energy, and that puts a shock wave into the water around it. There have been cases, or suspected cases, where remote vehicles have had a camera casing implode, and the shockwave from that has damaged other components. So this being while this could handle 6,000 meters, it wasn't a surefire thing that it was not imploded by the adjacent wreck. So this thing survived, but it was exposed to those kind of shockwaves. You can see gouges and damage on the surface. They basically take the casing apart and they find the interiors. And the developer of the board, the hardware, Rayfin or whatever, Subsea Technologies, they asked for redactions of various chips. What they did find was that while the interior was not compromised, there was no damage that had smashed through, they did, however, see mechanical damage. Components had literally sheared off. So think about it. The case is intact. The interior has not been damaged, has not been directly exposed to anything, but the whole camera case has been shaken with such violent force that the circuit board that was plugged into it sheared off. Just think about the force that it takes to do this. It must have had thousands of G's of acceleration as the interior collapsed. That gives you an idea of how quickly this thing moved and how quickly this thing stopped after the event. So anyway, one of the circuit boards has a secure digital memory card, and it was found undamaged. Oh boy, again, it's redacted, but that is the SanDisk Extreme Pro something or other memory card. I don't know why. I don't know why they decided to redact that, but they did. So they took an exact binary image of the SD card, right? So this is an important thing. When you're working with digital data, where possible, you take a copy and you work off the copy. You try to avoid using the original unless it's absolutely necessary. So it was determined that the memory card was partitioned into a small area for holding operating system updates before they were applied, and a much larger partition that was consistent with being fully encrypted. The further examination revealed that the operating system version in the update partition was from 2016 and would typically have used file-based encryption to encrypt its user data partition. The larger data partition was encrypted with full disk encryption, older method used by various operating systems. So basically this is running something based on Linux, but there was no, they couldn't find the crypto keys. So they couldn't find any keys on the card which would enable them to decrypt it. So Subsea Imaging, the manufacturer of the camera, initially confirmed that the camera data was stored on the SD card and they could download the data from the accident card at their office in Canada. But they later got back to them and said, actually, no, we can't do this. So what they were saying is like, oh sure, send us the SD card, or send us an SD card, and we can just like plug it into one of our development boards and read it, right? Once they looked at it, they realized that no, actually, the encryption keys are specific to each device. So they couldn't find the encryption key on the SD card, and it didn't contain a boot partition for the camera. So the camera hardware runs a little Linux system, and it wasn't booting off the card, it was booting off of something else, right? So they found the main system was a system on module board, right? That's basically an all-in-one computer like a Raspberry Pi. It has a CPU, it has like memory, it has like some storage, non-volatile memory, and a whole bunch of ways of connecting it out to other peripherals. So this is what it looked like here, and again, it's all redacted, but I think this is, oh yeah, I've actually looked this up. It is an Inforce 6601 micro SOM, right? So this is running like a Qualcomm Snapdragon 820. It's designed for video encoding, HDMI, all this other stuff which makes total sense, and it tells you it comes with 4 gigabytes of memory, LP DDR4, and 64 gigabytes of UFS flash storage. So that would be, well, these are power chips. I'm guessing that must be the flash, because these are definitely power, with all these like resistors around the outside. Those are capacitors and others. Yeah, these are for power conditioning. That might be your memory. I don't know. I'm not, I'm not an expert on this. I should just shut up. So yeah, they pulled this out of the card, and they found that the system on module was damaged, so it probably would not run. It was likely the camera manufacturer may have never attempted to read the SD card directly, since that would require disassembling the camera. That would add wear on the water protection seal, therefore the SD card would always have been accessed by a device connected to the back. So this is them saying, this is probably why the manufacturer thought they could read it and then realised they couldn't. Now, depending upon how the system on module was configured, it could have stored like encryption keys in the NVRAM, or is the trust zone system. It would effectively mean that the key would be stored on the CPU. Yeah. If the CPU was damaged, keys in the trust zone would be probably lost. Yeah. So the board manufacturer was contacted, and they provided a sample operating system install with the boards that they shipped on, and that they did not knowingly set up encryption. They also confirmed that the keys stored would either be in the NVRAM or in the trust zone. So they have two options of getting this. They have a board, and how do you get it? Well, if the data is in the NVRAM, what do you do? One way is you take the NVRAM off, and you back it up using like a flash reader, and then you use software to attack it. You basically try to build a version of the system on module that talks to this RAM and have it run through all the stuff, right? The other way is you take that chip and then you put it on another example of the system on module, right? The other example of the Inforce 6601. Basically, we're swapping that up, boot it up, and it should start working, right? So the software route is problematic, is nicer because it means that you're not having to solder and unsolder those memory chips as many times. The downside is that it requires a lot more work because you have to actually develop a whole software stack. The hardware one is a bit riskier because you're doing more operations. So the first thing was to get the NVRAMs off the chip, and they actually have a photo of this here just to get an idea of how small this is here. So they're basically taking the NVRAM chips off. They said that it's a universal flash storage device. They found a chip reader that would work with it. They read the chip with a UFS reader, and they looked at the contents of the NVRAM. They found it wasn't encrypted, but they couldn't figure out where the key was for the SD card. It was likely hidden in files, and they needed software to be able to read that, and the manufacturer was reticent to give them the software to do it. And I think partly this is because this manufacturer, it used to be in force, but by the time this accident had happened, there had been some mergers and acquisitions, and it was essentially a different company selling different products. This was an old product, it wasn't really supported anymore, right? So yes, they got a good copy of the NVRAM data, and they decided to focus on the hardware route. They copied the cameraman, they talked to the camera manufacturer, and they said that they could get a board from them. They could put the chip on that, but they couldn't provide the ancillary equipment. So the deal was made that they would get the boards, these system on modules. They would put the NVRAM chips on there. They would actually use one that was the original, and then they would have a copy of that made from their flash reader. They would put that one on a board, and they shipped those up to Canada. Or actually, I think they traveled up to Canada with them, and also with copies of the SD card. They went to Subsea Imaging's office, and they sort of plugged it into Subsea's dev kit, booted the system up, and they were, in fact, able to read the SD card contents. This is their test setup here, running the flash chip. I think this is probably the copy bit, you know. Just imagine, maybe that has been recovered from the deep sea ocean. So what did they find? They found 12 still images and 9 videos which were recovered from this device. So that was a breakthrough. That was exciting. Now, the next thing is that they actually looked at them, and that gives you an idea of where the camera was located looking forwards. Gives you another idea of where it is. Now, based on this image, they were able to date it to May of 2023 that showed that it was operating on a dock. They then found another image which they couldn't really date, and a bunch of other images that they couldn't date, and one that was in a place where it shouldn't be because somebody had, you know, misconfigured it. But basically they figured out that none of the images or video on the card were from Dive 88 where the accident happened. So this probably meant that the camera was operating in a mode where it was taking the data, dumping it off through the cable to those PCs inside the hull, and that's where the imaging data was stored. And so they basically concluded that there was no data there available. But yes, this image here was from May 16th, 2023. So again, boy, this was definitely a case of the journey is more interesting than the result. But I thought it was absolutely fascinating to see the state of that hardware and the steps that the NTSB went through to recover this. And so that brings us back to the NTSB report. Now, there's actually not a lot of new stuff in this. A lot of the conclusions are things that we could have previously reached, but I kind of want to just go over their sequence of events here. So, like, the NTSB report does look at everything. They look at, like, how was it managed? They look at whether it could have survived, you know, whether they could have made different decisions for the search and rescue, right? But I'm really going to focus on the scientific material analysis because that's sort of my jam. So one critical event in this story is Dive 80. That's the one where they go down to the Titanic. They spend a bit of time there. I think they have a problem with potentially getting stuck, but that's not the big news. It's on the way back up. There's a big gunshot style sound, and this is data from the acoustic monitoring system, which pretty much shows this event, right? So this is the real-time monitoring sound system. These are like peaks where like audible cracks and stuff are heard. This is the depth going up, going down really, and then reaching a maximum as they, you know, hang around at the Titanic and, you know, rubberneck. And then this is them coming back to the surface. And then as they approach the surface, there's this bang, big, loud noise that everyone hears. Everyone inside and people in boats on the surface somehow hear this sound. So yeah, there's a big acoustic event, and simultaneously the strain gauges which are attached to the inside, and this is a group which I believe is on the bottom near the front of the vessel. This is the strain, I believe this is the hoop strain, right, which is the circumferential strain, and this is the longitudinal strain, that is the strain along the length of the cylinder. Again, as the pressure goes up, as they descend, this feels more and more strain, and then as they come down, they get to this point where there's this big acoustic event, and suddenly the hoop strain jumps back up, and the longitudinal strain, it jumps down. But the important thing is there is this discontinuity here, right? Something loud, that loud noise was something giving way. Now, when Stockton Rush was asked about this, he said, "Oh no, it's probably nothing to worry about. It's probably just the submarine shifting in its cradle. It's nothing in the carbon fibre." And I understand why you would say that, because if they thought it was the carbon fibre, the right thing to do would be to take it out of service and you analyze it with like x-rays and stuff to see if they can see any defects that have formed. Now, what is believed to have happened here is this is a delamination event between some of the different layers of the hull. Now, carbon fibre, as you know, is built up in layers using these winding machines. They would put it on a big cylindrical mandrel, then they would wind like two longitudinal layers, and then two circumferential layers around the outside, and then they would run a longitudinal layer along the outside. And you would build hundreds of layers, and then they had a problem where when they did these big winds, these like 5-inch thick hulls previously, they had these wrinkles that would form on the surface, and wrinkles would be weak points. They would be weak points under buckling strain, and they actually caused test models to fail in test facilities. So instead, they came up with this process to remove the wrinkles as they developed. They would take it off the mandrel, grind it down, and then put it in an autoclave, heat it up, so that it was baked and the resin was hardened, and then start another layer, another inch-thick layer on top of that. These things would be glued together with an adhesive, and it appears that the adhesive between layers 1 and 2 and between layers 3 and 4 had a tendency to break. So that meant that the layers of the hull were no longer particularly well connected. So it's believed that this could well be a delamination or a separation event between layers 1 and 2 near the front of the submersible. Anyway, as we said, Stockton said, no, it's nothing to be worried about, and they continued diving. And that means we have strain data before and after this event. So this is the strain gauge. Again, it's showing as they descend, right, the ocean depth increases, the gauge output increases. So you feel more and more strain as they go down, and then the strain goes up as they come back. And there is a hysteresis thing involved, which I don't quite understand, but I'm sure somebody will explain to me. So dive 75, very nice linear response. Now, take a look at dives 81, 82, and 83, because they dove 3 more times after that big gunshot style sound that freaked out a lot of people. And now the thing starts as a curve before it reaches this sort of linear section. What's going on here? Well, if you think about it, these strain gauges are attached to the interior surface of the hull. And as they're descending, the strain is increasing more slowly until they get to a certain depth. And how I would interpret that, and maybe this is wrong, is that if you've got the first layer now separated from the outer layers, those outer layers are essentially carrying more of the outside pressure until they get pushed in far enough that they start contacting the first layer again. Then they start to communicate the pressure. So I feel that this is just down to the outside layers not really communicating the pressure inwards as effectively as they once did. So something in the hull basically changed at this point. So there were 3 more dives to Titanic depth, and then they went and stored it outside on a dockside in freezing weather in Newfoundland. And that could have damaged it in some form, right? That could have caused some changes. The other problem they had was they switched over to a new deployment system where they basically towed the submarine behind the ship on its launch system. And so that meant it was subject to some banging around in the waves. And there was also an incident during that season where they had trouble docking it back onto it, and I think they got the rear legs latched, and then the front legs wouldn't latch, and as it was rolling around in the waves, the front was repeatedly banging onto the surface. So these are 3 possible things that could have damaged the structure in some way. And so in the 2023 season, there was no actual deep dives until dive 88, the casualty dive, and that's when it failed. So you have this system of events, the sequence of events where dive 80, it gets damaged in some way which isn't investigated. They store it badly. You know, if you're storing it in water outside in the freezing temperatures, water can get into various points and it can expand. We've seen that in, well, the geology of the entire planet, right? Freezing water can break things. And that could definitely be a factor if it managed to get in. And look, if you're at the bottom of the ocean, there's a lot of places where water can get in at those pressures. Or it could just be repeated damage from transportation and stuff, which really pushed it beyond its limits. Okay, so now knowing the story of the damage to the hull that led to the failure, can we get any more clues as to what the actual failure was? So a lot of this data comes from actual examination of the wreckage on the seafloor and the materials which were analysed in a lab. And this was all published last year, but I'm going to go over it again because this is now the NTSB's official conclusion. So this is like what they found on the ocean floor. The rear section still had most of the carbon fibre inside it because, of course, everything gets kind of squeezed in quickly. The front section pops off because as the water comes in, it rebounds. Well, the rear didn't rebound like the front section because it has a fairing attached to the back of it with extra like syntactic foam and batteries. So it couldn't get pushed away. That's why it remains with most of the material. The front section, of course, had the window in it. The window gets popped off. The window was not believed to be relevant to this. While it was a non-standard design, it doesn't mean that it was involved in any way beyond getting pushed out of its mounting, and it was never found. Anyway, so the ROV is analysing this. They identify various interesting pieces. They can see all the way around that there's these separations between layers 1 and 2 and 3 and 4. This is like consistent across the entire circumference of the material that they found. Now, they then take a look here. What they've done is they've taken the ring and they've pulled it off and then looked at it from the other side. And there's a really important piece D here, which shows a buckle. A bend. So all the material is basically bending in one direction, right? Bending in one direction. This one bends in one direction and then the other direction. So this is an example of a buckle, and it's a buckle where I guess it's aligned with the longitudinal axis. It runs along the cylinder. So when you have a circular pressure vessel that's being squeezed, then it's like a bridge with no endpoints, right? There's no weak points, but if you find one weak point, then the whole thing will begin caving in. And a weak point could be where a buckle starts, and that changes geometry and then allows like the rest of the stuff to collapse. So why would this buckle be aligned with the length of the thing? And this is where we come to those wrinkles which we've previously mentioned. So this is an example of an end piece which was cut off the first Titan hull. That's the one that was taken out of service before anyone got killed. Now, this is the end piece there, and you see this wrinkle that had developed all the way through the section, and it gets thicker and thicker as it goes out. Now, an important thing to realise about carbon fibre is it's laid up in these flat layers, right? And the layers go in two different directions, but it's very strong within the layer. But moving across the layers, it's weaker. So now, if you imagine that you have compression coming in from the left side and from the right side into this wrinkle, then as it hits there, the layers sort of turning outwards will tend to transmit that compressive force from the side outwards, and it is weaker along this direction here. Also, because this is thicker, there's actually more resin in here and less carbon fibre. There's the same number of layers of carbon fibre, but the distance between them is greater in spots, and therefore it gets weaker. And now, if you then add on top of that you've segmented your hull into like 5 different segments held together by a dubious glue, then again, this buckling force that's pushing outwards is being transmitted through these glue layers, which have very different properties. So again, you got to understand what a buckle is. If you take a look at my fingers, they're sort of pushing the pressure together, right? And as soon as as long as I keep my fingers straight, I can put a lot of force into there, right? But if I let them move sideways, the whole thing pops in, right? See, it's any disturbance off of center suddenly becomes a lateral force. And that's what these wrinkles are essentially doing here. They're allowing paths for this compressive force around the circumference to translate sideways. And since these ran up and down the pressure vessel, they would be natural points where the failure would happen. Now, on the second pressure hull, as I said, they went and ground these things down because they saw that they would get worse and worse throughout the radius. That was their concern, but then they used these glued sections, and we saw that in the recovered or the analyzed sections that there were voids in the glue where it basically wasn't being held at all. We also found segments where the sections had visibly rubbed together along the longitudinal axis. There were voids elsewhere in the structure between the composite plies. So this material could have been made better, but honestly, when you start finding defects like this, right, you find these defects in the analysis, what do? You make it thicker, you add more layers, right, until you do get the safety margin you need. But, that's not what happened. So anyway, that's sort of the state of play with this. I don't think we're going to see any more major reports. There might be a few things that get released over the years, but I think by this point everyone has decided and understood that the engineering decisions made by OceanGate, and specifically driven by Mr. Rush, that very much led to a submersible which was below the performance that was needed. And then the misuse of the real-time monitoring system data meant that they didn't see when it was going to fail. If they had had the right system, they could have seen the changes after dive 80 and they could have took it out of service. But they didn't do that. They didn't have it plotted in the correct way, and the guy at the top didn't want it to be taken out of service. And then there was compounded by the storage, the transport, and various other issues, which finally led to the failure. As I said, I don't think there's going to be much more released, but there's a lot there to read, a lot of really interesting analysis here and there, and I like reading these really technical things. If you want to read a more general, if you want to read just one report, this is the 300-page Coast Guard report, which also incorporates a lot of the NTSB stuff. They have a lot more detail in here on specific things that happen at the at the government level and the various interactions with employees and ex-employees at OceanGate. But the other one that is worth kind of reading just for fun is the NTSB investigation with Mr. Redacted, who apparently directed Titanic and some movie called The Abyss in 1988. This is full of all sorts of really interesting gems. Yeah, sure, he does make movies. He is a movie director, but like Elon Musk was a software guy until he became a rocket guy. It requires a lot of interest and dedication and work, and you can become an expert in the field. And I fully believe that James Cameron is he is very capable and worth listening to on this thing. A lot of his real comments come down to we've worked with Titan Submersibles. We know they're good. We know they have good safety margins, and we should make sure that whatever happens going forward, that we're not penalizing people that are doing things properly. Like, one of the cool things I found in the James Cameron story is they talked about working with a metallurgist who pointed out that they used a material called 300M for the hatch, which had a microscopically different bulk modulus than the EN26 that they used for the rest of the sphere on the Deep Sea Challenger. And that meant that the hatch would expand and contract at different rates under pressure. And so there was a possibility that after they had taken this to depth, the hatch would reseat in a position which would make it impossible to remove. So they could be jammed inside there, right? So they had to redesign the shape of the hatch seal so that the hatch could not get pushed into a position where it would be impossible to remove. These are the kind of details you have to deal with. There's a lot of stuff that's worth reading here, even if you're not the kind of person that is rubbernecking people that died at the bottom of the ocean. I'm Scott Manley. Fly safe.